Okay, students, in this video we're going to be learning about bases and exponents and the rules of exponents. So the first thing we have to do is let's figure out what a base is. A base is simply the biggest number that you see there. So you can see that we have a 10 and a 4. The large numbers, we call that the base, and that little superscript, which in this case is a 4, that's the exponent. So we're basically going to be raising 10 to the 4th exponent, and I think you guys are familiar with that concept already. A couple of other things we have to talk about is some rules, and I think the most basic of all rules is the idea what happens if a base doesn't have an exponent. You can see that the 10 doesn't have an exponent, so what you have to remember is this. If there is no exponent, remember there's always at least a 1. We've talked about the use of 1 quite a bit, so if you look at something and it doesn't look quite right, sometimes we can put a 1. So if you don't see a 1 there, if you don't see an exponent on the 10, you need to remember there's always a 1. The next rule I think we need to talk about, and you can see me putting a 1 on that 10. The next rule that we need to talk about is the idea of what do we have if we have an exponent of 0. So it's really important to remember anything to the 0 power, it's not equal to 0, it's equal to 1. So you can see on problem number 2, peeking over there on the right hand side, we have 2 raised to the 0 power, so we're going to look at it here in just a second. So anything raised to the 0 power is 1. So if you look at 2 to the 0 power, that 2 to the 0 power is really 1. So you can test it with your calculator. So if I take 1 times 2 to the 3rd times 2 to the 5th, that's what that problem really is. So you can kind of ignore that 2 to the 0 power because it just goes to 1. Okay, the next rule, and this is where we're kind of getting into the meat of things, really what we want to talk about is this third rule. And it states that to multiply like bases, so 10 times 10, they're like bases, we simply add their exponents. So to multiply like bases, that mean like bases means they're the same number or the same letter, the same variable. So to multiply like bases, we just simply add their exponents. So those are the first major rules that you really have to that we really have to talk about. So you just add their exponents. Yep. So we're going to do a couple of problems here, problems number 1 and number 2, and then we'll talk about some more rules. Okay, number 1, we have the 2 exponents, 1 and 4. We have our like bases, so we add 1 plus 4 gives me a 5. So we keep the base. That base is 10, so it's 10 to the 5th power. That's how simple that rule is. Now let's go over and we'll look at number 2. That's the answer for number 1, 10 to the 5th power. Let's look at number 2. Now remember on number 2, that 2 to the 0 power goes to 1. So all we really have is, the only thing that we have for bases is 2 to the 3rd and 2 to the 5th. So we take 3 plus 5 will give me an 8. Remember 2 to the 0 power is 1, so 1 times 2 to the 3rd times 2 to the 5th, that is just simply 2 to the 8th power. So those are the first 3 rules. Remember that there's a 1 and understanding what anything to the 0 power is. The next most important rule that you'll learn how to use is what we call the quotient rule. And the quotient rule really has to do with division, and the type of problems that we're going to be doing is they look like fractions, and some of them will look pretty bizarre here in just a minute. But the idea is this: you're going to have 2 bases. The base with the bigger exponent is going to subtract the base with the smaller exponent. We're really not subtracting the bases, we're looking at their exponent. So if you look at 9, 9 has a 5 where the bottom 9 has a 3, so the 9 on top has a bigger exponent than the bottom 9, which is a 3. So we're going to take that 5 and we're going to subtract 3. So if you see those two things right there, the 9 on top has a bigger exponent than the 9 on the bottom, so we're going to take 5, subtract 3, and we get 2. So there's where the rule of the bigger exponent subtracts the smaller one as far as their bases. And so now what we do is 9 to the squared power, and that smaller base, the base that has the smaller exponent, I guess I should say, will always go to 1. So we have 9 squared. Now let's do it down here. Now you can see the 8 doesn't have an exponent, so remember the rule of 1. If there's no exponent, I can use the 1. So that problem becomes 8 to the first divided by 8 to the seventh. Now the seventh has a bigger exponent than the 1, so I take 7 minus 1, and I get 8 to the sixth. And since 8 to the first is a smaller exponent, it goes away. But again, remember there's always there's a 1 right there. Okay, now in this next part, we're going to show these problems will show us how to use the 4 rules that we've already learned so far. So we're going to combine all our rules together. So we have 6 to the 4th times 6. Remember there's a 1 right there. So we'll take the 4 plus the 1 will give me the 5. So now on the top, that top base has 6 to the 5th. The bottom base has 6 squared. So now I'm going to use the quotient rule. 5 is a bigger exponent than the 2, so 5 minus 2 will give me a 3. The bottom exponent that goes away, I'll use a 1 there, and the top exponent base will have the 6 to the 3rd. So there's my answer. Or you could write it as 6 to the 3rd. Either one of those I would take correct on a paper test. Okay, let's do the next one. Now remember 5 to the 0 power, anything to the 0 power. Don't forget that. That's a tricky one. That will go to 1. So I have 1 divided by 5 to the 3rd times 5 to the 4th. Now we're multiplying like bases on the bottom, so we don't subtract them here. They're both on the bottom, so that's 5 to the 3. It's 3 plus 4 will give me the 7. So that will end up as 5 to the 7th power on the bottom, and then that 1 stays on top. So those are your rules, and thanks for watching.